Welcome everyone joining us for this webinar series. I'm actually having second thoughts about this topic now for the webinar because you might think that actually we're going to be sharing just some general mistakes that people have made along the way and some common ones that you would find, but actually no, we're going to be sharing with you some of the mistakes we have really made along the way, personal to myself and Troy, that we have done so that you don't have to go through the same embarrassing mistakes that we have in the past. So we're going to cover some of the things of what not to do and why, and maybe even sometimes why you might want to bend those rules with lots of real nice demos and examples as well. But before we get started, Troy, why don't we do a quick round of introductions?
Yeah, absolutely. So on the call, not needing an introduction, but we have Matt Starling, Senior Director of Product Marketing and ECSE, joining us from all the way over in the UK. We have Dale Tyler, Senior Sales Engineer, right? Who'll be answering your questions in the chat, pitching in when he can, sneak in some conversation between Matt and myself. Unfortunately, Stu Goomans wasn't able to join us today. He's out in the field working with one of our partners. And then lastly, there's myself, Troy Martin. So welcome everyone to today's webinar.
Yeah, and who knows, maybe Stu might sneak in at some point and then jump into the chat and Q&A, so you might see him in there sooner or later on today. But first of all, worst mistake number zero, before we get into them, I think this could be one of the real bad ones, I would say, Dale. Don't you agree about people not signing up to the Ekahau Slack or user voice?
Absolutely, it's a must. I think we need to inform those that aren't aware. So, if you're not aware of our public Slack channel, we do have a space available, a Slack channel, a whole channel out there, a lot of different Slack spaces out there. So, here's the QR code for that if you're interested in joining. It is public, so welcome to everybody. We extend the offer to everyone. Now, we also have our updated user voice feedback portal. So, if you have feature requests, new ideas, you want to give feedback directly to our product team, to the right, you'll see the QR code for that. So we definitely recommend that you take advantage of using either one or both of those features.
Thanks, Dale. And first of all, then, should we kick off a quick poll question, Troy? If you read out the poll question, I will figure out where I go to launch it because it's been a while since we had one. Where,
Yeah, absolutely.
where do
So this is
I
one,
go?
if you've
Ah,
ever had the opportunity to revisit some of your designs that you've worked on, the last 5 years, depending on how long you've been in the Wi-Fi industry, maybe it's 10 years when you were just kind of brand new or green into the Wi-Fi world. You might have made some design considerations as going through the exercise. So what are common Wi-Fi mistakes that you've made? Have you ever looked at your old designs and thought, I am so embarrassed. I hope no one ever associates that design with me, right? Or you may have always been very confident with your designs, so you've thought that they've always been perfect, and there's no need for self-reflection. I have worked with some people that definitely fall into that category. Every design that they've ever done their entire lives have always been perfect. They never revisit them. They never get feedback from the field to see if there's anything that could have been improved. It's just always a perfect design from the onset, right? Or maybe you buy into the process of you continually audit your designs, right? You look for feedback, you look for the results of that validation data. Was there anything that you could have done different? Were there any assumptions that you went into your design that were wrong, right? Maybe you can correct them so that you keep refining or improving your design process over time, right? So some people buy into that philosophy, or other people, maybe they've really bought into the latest and greatest technology of AI that's now available that allows the basically the early stages of Skynet to take over their designs and place access points for them, right? Speeds up the design process. It's up to you how you want to bill for that. If you want to bill for a shorter amount of time, or if you want to bill the customer that, no, it still took 8 hours, even though it was one simple click of a button, right? So I'm curious to see how people land on this poll.
yeah, I mean, it seems like a few people shared the same embarrassments that I've had, maybe. About 40% of you said that you've had some of those scenarios in the past as well. But a big chunk of you, over 50%, say that you're always reviewing your designs for continuous refinement and improvement, which is good to see. And only a few of you have had the perfect design. So congratulations to all of you that have had that. Thank you, everybody. So we are going to now work our way through some of the mistakes. And first of all, number one is around channel planning. And I want to take you back in time now to 2013. This was me when I got one of my first jobs in Wi-Fi, and I was working as a wireless support executive. And bonus points for anybody in the chat that can work out number one, the vendor, and number two, the model of the access point that I'm holding back here. And okay. Oh, okay. The bonus points already goes to Jerry and to Harish. They
Boom, just like that. Hey, good eye.
yeah. Okay. They spotted that really well. Okay, yeah, but well done. So yeah, this was me going back pretty much when I first started working in wireless, and I was pretty new, so I knew a little bit about Wi-Fi, but I didn't have the depth of knowledge that I know now. I hadn't really taken any official trainings and things like that. And my role back then was to work in the support team. So our customers would call us up, they would tell us some of the problems that they're having, and we would try and identify them and resolve them over the phone. And I remember when I was listening to some of the more experienced people in the team talking with our customers. And I remember one time I overheard one of our most experienced guys in the team say that he helped fix one of the customers, the issue that they were having with the Wi-Fi by changing the channel of the radio that the access point was using. And I thought, oh, you know what? I'm gonna remember that for the next time someone calls me up and says that they're having problems with their Wi-Fi. I'm gonna change their channel. So anyway, fast forward to like the following week, someone calls up and says, "Hey Matt, I've been having issues with the Wi-Fi in our restaurant. Can you see if there's anything you can do to help or improve us?" And I said, "Yeah, don't worry, I got you covered." So I log on to their access point remotely. I check the channel that it's using on 2.4 gigahertz, and I can see, it's using channel one. I know what I'm going to do. So I changed the channel for them. I went from channel one to channel two. And I sat back and I said, "Yeah, don't worry, Mr. Customer. I've definitely fixed your issue for you now. Just give it a few moments and you're going to notice a big improvement." Anyway, so I put the phone down, and then I don't know, a few minutes later, the customer calls me back up again and goes, "Matt." I said, "Yeah." I was like, "Are you enjoying your new good Wi-Fi?" And he went, "No, it's got worse." And I said, "What? How's it got worse? I just changed the channel for you." I said, "Oh, don't worry, I'll change it again." And I changed it from channel two to channel three, and I thought, "Oh, I've definitely fixed it this time." Turns out I hadn't. I'd made quite a bit of a mistake here because on 2.4 gigahertz, we only have a certain amount of channels that don't overlap with each other. So in the 2.4 gigahertz frequency band, you want to stick to a channel 1, 6, 11 channel plan in most scenarios. Yes, you could potentially do 1, 5, 9, 13 in some places around Europe, but ultimately, most of the time, you want to stick to 1, 6, and 11 because if you use any channels in between that, what you're going to cause and create in the environment is something that's called adjacent channel interference. And that's exactly what I did. So I didn't realize that channel one didn't overlap with channel two or channel three. And because it did, it was causing the Wi-Fi to be a lot worse. And a real simple way I like to think around when it comes to co-channel interference and adjacent channel interference is the difference between access points speaking the same language and understanding what they're saying. So imagine you've got access points communicating and they're speaking in English. They can understand how long you're going to take, wait their turn, and then take the time to speak when they want to. However, if you've got access points that are some speaking in English, some in French, some in German, some in Italian, and they don't understand what they're saying or how long they're going to say it for, they end up trying to talk over each other, and it causes lots of noise, lots of interference, corruptions, and retransmissions. So we want to, as much as possible, try and avoid having adjacent channel interference. If you have to have some channel interference, which we know we will run into that on 2.4 gigahertz in most situations, it's much better to have co-channel interference rather than having adjacent channel interference. And then generally, this is a picture of me and my face with my headset on in the support team back in 2013 when someone explained to me what I had done and the realization that I'd come to. So yes, definitely want to try and avoid that at all costs if you can. Okay,
Yeah,
what's the
it's so
second?
true. It's a classic mistake. I remember working for a partner, and we decided that we were going to do lunch and learns to ramp up our team. And so we had each kind of a guru on the team. There was a wireless person, security person, data center person, collaboration person, and we each spend 1 hour trying to ramp up other people in our team and teach that technology. So my turn came up. I was the wireless designated person there. So I started trying to explain what I thought was super basic concepts in Wi-Fi. So we started talking about the 2.4 channel plan, why channels 1, 6, and 11 are the non-overlapping ones. And these are all like super smart people in their specialty in IT. And I explained the concept of non-overlapping channels and why 1, 6, and 11 makes sense. And half the room, it's like I turned on a light bulb in their head. They're like, oh my goodness, that's so amazing. I've always wondered why that was the case. Right. And for me now, looking back, like it seems such like a fundamental concept in Wi-Fi. But if you're outside our Wi-Fi bubble, why wouldn't it make sense to move from channel 1 to channel 2? Right. It's a different channel number. If you don't know, it seems kind of obvious, right? And I think that's one of the traps a lot of new people into Wi-Fi end up in, is they set those wrong channels. Another thing that Matt pointed out in the slide of recommending the 3-channel plan, 1, 6, and 11, as we move into a world that's increasingly adopting IoT technologies, things like BLE or Zigbee, Matter, Thread, those type of IoT technologies that are used for building automation, controlling HVAC systems, turning on and off lights, guiding people up and down hallways or convention centers, that kind of stuff. A lot of those technologies are designed to coexist with Wi-Fi. And so some of the BLE advertising channels, or if you specifically select the right Zigbee channels, those channels will fit in between the Wi-Fi channels, right? In the gaps in between 1, 6, and 11. And so carefully planning your Wi-Fi will allow you to coexist with those other wireless IoT systems that we're seeing more and more pervasively deployed across our environments. Right.
So
The next thing that we wanted to talk about,
no, go ahead, Troy.
is the wall the wall attenuations. And a classic Wi-Fi design process that we go through is we load our floor plans into our predictive model, and then we have to start drawing walls, right? So that we can model the attenuation of the RF signals as it propagates our environment. And this step, although it sounds simple, just adding walls, it's one of the most challenging parts of the predictive design to get accurate, right? Because at the end of the day, our goal in the predictive model is to make it as accurate as possible to match the real world RF conditions that we have in our environments, right? But in order to do that, it ends up being a task of risk mitigation. How do we decide what attenuation value to use for our different material types so that we get the correct model that we can then look at all these what if scenarios of what if I put an AP on the ceiling, on the wall, like a clock, underneath the floor, or other spots, underneath desks in hotels where you might have the 3 or 4 switch ports built into the access point. So it becomes a challenge to come up with these wall attenuation values. Now you could go to site to help reduce some of your risk. You go to site with some sort of access point, you set it up temporarily, and you take some spot check measurements of the walls that allows you to characterize some of those wall types. But as you do those spot check measurements, you may only be measuring one portion of the wall, right? Where 10 meters along the wall, they actually covered up brick, or some scenarios you find in a lot of old hospitals, right? Hospitals that are 80 years old, what they often like to do is they move the radiology department from one wing to another, and they leave behind the lead-lined walls, right? So from visual inspection, it looks just like a regular drywall, but underneath it or inside, there's a whole bunch of lead that offers significant attenuation to your model, right? And if you don't capture and reflect that accurately, you can run into a lot of inaccuracies as you put together your model, which can significantly change the number of access points or the placement of area APs, right? So Matt's going to walk us through a little demo of how you can see the impact of different attenuation on walls in your design.
And what Troy mentioned there actually happened to me many years ago. I used to do hospitals all of the time, and what I've got here is I've just got a snippet of a small section of a hospital here, and placed access points in kind of all of the rooms. And I've assumed that the wall attenuation values for the drywalls is 3 dBs, and for the office doors they're 4 dBs. But I remember once when I was doing the hospital, I'd surveyed so much of it. I was doing AP on a stick, and I managed to get into quite a lot of the rooms, but there was a few sections of the hospital that we just couldn't get access to. And it looked on the floor plan so similar to other areas of the hospital. So I just decided to make a an assumption that yes, they would have these walls here would have the same amount of attenuation as the other walls that I had measured, and I didn't actually go there and do it. So when I did my design, I designed it with the same amount of access points as I thought it would need for the other area. And I think what you would agree here is looking at the coverage, the primary coverage you can see at the moment, we have signal kind of everywhere that we'd want inside of these rooms based on the attenuation values that we've assigned to these materials. But what had happened to me here is exactly what Troy said, is the fact that there was actually drywall covering up other materials, and it was like drywall covering brick or concrete or something like that. So going from 3 dBs of attenuation, it was actually something crazy like 12, 13, 14 dBs of attenuation. So if I go in and change the value of this drywall now from being 3 dBs to, I don't know, say, let's make it 12, look at the difference in coverage straight away that you can see how much that impacts it. And if I change the attenuation value of the doors as well, to maybe something like 14, and we look at this same heat map pattern now for the access points in these rooms, you can see how much of an impact it has on the coverage. And what burned me or hurt me in this scenario here is that after they installed the access points, the customer complained about not having good Wi-Fi in some of the rooms. And I was like, oh, how can there be no good Wi-Fi? I came to site, I measured, and I realized it is in the only a few areas I didn't go to. And I had to retrospectively go back, measure, test, and then I realized that there was really thick walls there. And I had to update the design and retrospectively say, yes, you need more access points, you need to run more cables if you want to have coverage in there. And it wasn't an easy or a nice conversation to have. So a big tip from us here is don't fall into the same mistake that I did. Make sure you go and measure, make sure you go and test, because if you make these assumptions, sometimes you'll get it right and you'll be fine. But if you get caught out like I did all those years ago, you definitely remember it. It still keeps me up sometimes at night thinking about that mistake that I made and having to tell the customer they need to buy more access points and run more cables, because that was a real challenging thing to do in a hospital at the time. So definitely avoid that as much as possible. Okay. So now we have the poll question about the orientation of the access point.
Yeah, so we're talking about different strategies that you have thinking about how you place your access point, right? So are you one of those people in team horizontal where you always place the APs mounted as if it was on the ceiling, so a nice horizontal mount, right? Or do you believe access points should be treated like aesthetic beauties, right? Mounted on the wall, treated like a picture, showcase, maybe get the architects and the designers to paint a border around the AP so it becomes artwork that you can appreciate within your hotel rooms, right? Or maybe you default to 42, right? It depends. Or you think more about the propagation of the RF pattern, right? Where it's going, buying into the mantra, cover what you want, not what you don't want, right? Or do you just tilt all of your access points or antennas to a sleek aerodynamic 42-degree angle to maximize the bleed, the RF propagation as it burns past the access point? So I'm curious to see where everyone lands in this poll.
Yeah, and again, I'm so sorry. You would think that I would have learned how to do this by now after however many years. Apologies for launching the wrong question at the wrong time, but thanks for saving me a bit there, Troy. It does seem that a lot of people went with it depends, cover what you want, whilst not covering what you don't want.
Yeah, so it could be a lot of people that just couldn't commit to an answer. Sometimes that's what happens when we see it depends, right? And part of this and kind of the goal of this webinar is learning from our mistakes. Is if you don't know enough about Wi-Fi, you don't even know what questions you need to ask in order to quantify what the requirements are and to help you decide which antenna and where you should place that antenna. If it's horizontal or vertical, maybe it matters, maybe it doesn't. But to ask those requirements gathering questions helps you answer those it depends challenges.
Okay, Troy, then what is this next mistake that we see?
Right. So there's been a debate, and it's one of those classic stories in Wi-Fi design where you get 10 wireless practitioners together and you ask them their opinions on how you should proceed with the design. You'll get 11 opinions on what should happen, right? And so I find this is one of those scenarios, right? And what we're talking about here is how do you mount the access point? What is the proper orientation? Right. And to inspire part of this discussion, we have some pictures of some APs that are mounted in different scenarios. There's a picture on the left, which I imagine was initially an AP mounted on the ceiling, but it's been relieved of its mounting bracket, and it's now hanging, doing a stress test on the Ethernet cable. A little bit of a side story. We run into similar problems like this in Canada. It may just be a Canadian problem, but in winter at recess or at lunch hour, when the kids come back in from their breaks, they come in from playing hockey outside, and as they walk down the hallways in their schools, the access points become targets for their hockey sticks. So they'll take swipes at them, and you can see the marks on the ceiling of the tape from the sticks as they miss a couple times, but they'll actually knock the access points off the ceiling. So we'd have to put them inside enclosures to protect and secure them inside the hallways, which is kind of a weird problem. Other access points, you may be placing them in gymnasiums or auditoriums inside schools, that rooms that have really high ceilings, right? So you may be thinking, hey, I need to get my access point closer to my users, closer to the devices, which is a good strategy. But instead of mounting it, 40 feet up in the auditorium ceiling, you mount the AP on the wall like a clock, right? And if you attach the antennas, hopefully if you go down this path, you attach all of the antennas to the antenna ports so that there aren't any missing or not connected, like you see in the picture there. And then the last picture, I was just recently at an airport, going through the security area where they scan your bags. And as classic Wi-Fi people do, we stare up at the ceiling, we look at access points. And I was thinking, this is really funny. There's an AP mounted on the wall like a clock, but there's 3 cameras looking at this. And so I had it in my head, I'd make a little quick jib about, look, these cameras are so excited about the Wi-Fi at this location that the cameras are focused and looking in on the access point. Now, the security agent who saw me taking pictures of the walls was not impressed with what I was doing. So she came over and interrogated me, and I almost wasn't able to board that flight. I'll save the details of what happened after that, but it was a bit of a disaster, right? And so one of the things that you want to think about as you place your access points is the mantra of covering what you want while not covering what you don't want, right? So most of the access points that have the built-in integrated omnidirectional antennas, they produce what we generally describe as a cardioid shape, right? So when you mount that access point on the ceiling, it shoots out omnidirections out and around, with the bulk of the energy going down onto the floor where you want it for your users, right? There's not as much energy going up to the floor above you. You're not wasting that energy lighting up, a cubicle or 2 above you, but the energy is focused and directed where you want it, right? Which is a good approach. And that's the reason that a lot of those integrated omnidirectional antennas, it makes a lot of sense for them to go on the ceiling, right? And there's a big push to have them in that orientation. You can reach out to vendors of different manufacturing brackets where you can get little 90-degree arms that stick out from the wall. So that AP that we had that was missing its antennas in the auditorium, you can get a little right angle bracket, mount that access point to that bracket so that it's oriented as if it was mounted on the ceiling, although it's very close to a wall and it's not 40 feet or 15 meters or something crazy way up in the air, right? Now, going back to our mantra, cover what you want while not covering what you don't want. I am not opposed to APs on the wall, right? If you want to mount it like a clock, that's a completely valid orientation, as long as you can understand that you're covering what you want and you're not shooting RF energy where you don't need it. So if you imagine a 1-floor school that doesn't have floors above it or below it, or imagine putting APs in a stairwell where you want to shoot some RF energy on the stairwell that goes down as well as the stairwell that goes up, so you can cover kind of the 2 flights of stairs. Mounting an AP on a wall there, as long as your RF energy is covering what you want and you're not creating interference in locations that you don't, it can be a very effective strategy, right? And some people will talk about, well, what about the electrical propagation patterns and the magnetic propagation, the polarization of the electric fields, all that kind of stuff. And it's definitely something to think about. But if you imagine users and their phones, right? If I have an AP on the ceiling and a user holds their phone vertical like this, you may have a good connectivity to the access point. But does everybody hold their phone like this? right? Some people are going to hold their phone flat while they flip their emails, watch their video. Some people rotate their phone like this. So the client devices themselves could be in a whole mix of different orientations, right? And a lot of the access points will have dual polarity in their antenna elements to help deal with different orientations of client devices. And because of that, there's less impact going from ceiling to wall mounts and impacting your polarization. And so as long as you're getting the coverage that you're looking for and minimizing those co-channel interference problems, that's what you should be focusing on, right? And if you can also check the box of making it aesthetically pleasing, that's always going to be a win.
Yeah, I agree. Sometimes getting APs and mounting locations past architects is some of the most challenging things you'll do when it comes to your Wi-Fi project. And kind of continuing on the same theme of worst mistake number three, not playing a big part in managing the physical installation of your access points and antennas after you've done the hard work of going to site, doing your surveys, doing your predictive modeling, providing a nice report to the customer, and giving it to the installation team. Not checking that they install the access points or antennas how you intended them to can really hurt your designs. And we've got a couple of examples here of access points not being installed quite as you probably intended them to be. So this one here is above the ceiling, not below the ceiling, and also just placed on top of a, I don't even know what that is. It's like some kind of like metal box. So again, like ideally not so great. And then here they've got the antenna installed nicely, but then the access point kind of installed below it. So not really too sure what's going on here. So yeah, don't know why that has happened, but again, one of those things that can genuinely happen. And then
They were
finally
really
this one.
impressed with their cable management on that one, though.
Oh, I mean, yeah, those cable ties are nicely wrapped, aren't they? But yeah, what is going on with the AP down here? I don't know. But um, the one on the right here again, like get up on the ceiling around all this piping not secured properly, just little things like this. When you repeat that over tens or hundreds of or thousands of access points not being installed as you intend them to be, it can play a big part on the impact of the propagation of the signal coming from the access points to your client devices. And another example here is of an access point that was in the ceiling, but it was surrounded by all of this metal ducting and piping and aircon, etc., etc. And all of this material or directly around the access point is going to play a big part and impact the signal coming from the access point. So a big tip here is making sure you don't just hand over your design, your report, your whatever to the stakeholder and then just walk away from it. Make sure you do go back and then interrogate, vet, make sure that they've installed them as you intend them to, because again, it will play a huge part on the performance of the Wi-Fi.
And the next mistake that we'll talk about is mistake number 5. It's a classic mistake. I've been guilty of this in early days. It's placing APs in the hallways, right? And this is, again, it's a case of if you don't know, you don't know enough of the issues or the impacts this can cause. A lot of the classic arguments is that we need the APs to be easily serviceable, right? If an AP goes down, we need to be able to send our technician, our maintenance person out to swap access points, right? We don't want to disrupt any of our hotel guests or patients in the hospital, or from an MDU, we don't need to, we don't have to give 24 hours notice before we walk into that room, that kind of thing. So to put APs in the hallway, it's often less expensive to run cables right down the hallway versus running a cable into each room or every second room or something like that. So there's a bunch of arguments for placing APs in the hallways. And if you don't know the impact of that on the RF side of things, you may not push back hard enough to say, no, 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 no. If we want good RF, if we want the RF to be at the best that we can make it, we need to put it where it matters, right? And so one of the stories that I like to kind of relay that concept is if you think about water sprinklers, right? If we only installed water sprinkler heads up and down the hallway, if there was a fire inside the room, right, they wouldn't be able to put out that fire. There's a reason water sprinklers go inside the rooms and that they're below the ceiling or the ceiling tiles or whatever it is, right? They need clear line of sight and they need to be in the location to spray the water to put out the fire because that's their purpose, right? Their reason of being, right? The same thing applies to access points. In order to get the RF where you need it, you need to place the access point where it can deliver good RF. So if you end up placing access points in the hallways, and you think about hotels as an example, you end up with a long serial line, which is essentially a waveguide from an RF perspective, right? So the RF signals bounce very easily up and down the hallway. Access points will see each other quite well. And if you leverage one of those auto RF protocols, when access points hear each other quite loud, they tend to turn down their power. And when the APs turn down their power, there's less energy getting into the rooms themselves. A lot of hallways, they end up being firewall rated, or there's a thicker material on the hallway walls. If you stayed in a lot of hotels, the walls in between the rooms themselves are quite thin, but the hallway walls are thicker. A lot of hotels will have, the washroom right against the hallway. So there's a couple extra walls. There may be a closet. There's some tile, giant mirror in the washroom. So you end up with thicker walls right against the hallway. And so there's more signal attenuation as the energy propagates into the backside of the room. A lot of hotels are set up with a little chair and a little table so you can enjoy your little cup of coffee in the morning, stare out the window. If you're in the US, you stare out the window and look at the freeway of all the cars driving by, and you get inspired for your day. But that's where users are often using their Wi-Fi, is way at the edge of that room, which is where the signal's the weakest. Right, so that's one of the challenges from an RF perspective that you run into by placing access points in the hallways. Another problem you have is with the signal propagating on the hallway like a giant waveguide. It gives the illusion to clients in the hallways that the signal's really, really good, really strong in those hallways. So as you walk down a hallway, you may be on a call or watching your video, or my kids have rekindled their drive to play Pokemon, so they're chasing Pokemons all over the place. And if you walk down to the end of that hallway, you round the corner, and then within 3 steps, you walk out of range of that access point, right? So it gives clients the false sense of a good connection, and it doesn't kick in or trigger their scanning algorithm, right? So they think the signal is really, really great. You round that corner, walk out the edge of the network, and they haven't started scanning, looking for other APs to roam and connect to, and they end up disconnecting from the wireless network itself, right? Which creates roaming challenges for those environments that need to deliver secondary coverage for real-time applications, voice and video services, that kind of thing, right? So you end up with a much better, a much more robust design if you're able to tuck the APs in the rooms and make a more rounded coverage pattern and avoid this long tail effect, right? This helps get the energy where you want it, where it's needed, and avoid shooting energy down these long tails.
Yeah, thanks for that explanation there, Troy. And by the way, this image that you're seeing, I actually did a presentation at a conference earlier this year, and someone reached out to me via email about one of me talking about not putting APs in hallways, and they sent over this example and showed it to us. And I don't know if that person is on the webinar today or not, but I did ask, oh, you know what, we're actually going to be talking about this in a few weeks' time in a webinar. Would you mind if I shared it? But the reason why I'm mentioning that is because if you are watching the webinar today and you have some interesting survey data or designs or things that you want to share with us, please do feel that you can reach out. We love seeing your real world examples and being able to talk about it and share it with others if you are happy to. So if you've got an interesting thing like this, or you hear us talk about something like, oh, you know what, that happened to me. I can see people in the chat saying stuff around this as well, saying these sorts of examples have happened to you as well. Do feel free. You can reach out to myself or Troy on email, on Slack, on LinkedIn, or whatever. We'd love to hear from you and see these kind of examples. And I thought it might be nice to actually try and visualize just some of those things that Troy was saying to you, rather than just looking at on the still graphic there. So if we go back to this file earlier that we was taking a look at, and if we just move some of these access points into the corridor instead of them being in the rooms, and we can maybe visualize a little bit just what Troy was saying in Ekahau. So now if I click on just like the signal coming from like one of the access points, the thing that Troy was mentioning is that when you go through some of it gives that kind of like false illusion that you've got a good signal strength for your client device, that you can see anywhere up to here before this, this heavy door, it's got quite good signal strength. However, as you pass through the door, the signal starts to drop down. But when you turn and walk around the corner, you can kind of see here where we've got this the darker gray to lighter gray, like the signal drops so significantly that it doesn't give the client device enough time to realize that it's going to need to trigger a roam to go and find the next best access point to go and connect to. Whereas if you put the access points in the rooms and you had the nice natural degradation of the signal strength as your clients are walking around and through different rooms, then that will give your client devices time to trigger that roaming threshold, to then go and search for another access point to go into, rather than kicking off one of those panic scans to then try and find the access point to associate to. And if that happens to one of your client devices and they're on a voice or a video call, you can pretty much guarantee that they're going to end up dropping that call or missing a huge part of that conversation. The other thing about putting the other thing, just to talk about the when you're planning your Wi-Fi designs and your access point positions, is you really want to think about where your users will be traversing through the building, because you want your access points to actually build up something called neighbor reports. So you want your access points to hear its next best neighbors that are going to be on the same path as the roaming trend of your client devices. So rather than your client devices having to go and scan all Wi-Fi channels to go and figure out which AP to go and associate to, if the access point can send in 802.11k the neighbor list of its next best neighbors that are actually in the roaming path for your devices that they're going to take, that can really speed up the process for your devices as well. So a few things to think about there. Okay, Troy, what's number
Yeah.
6?
Yeah, number 6 is not managing the configurations of your new deployments, right? So you've created the best design that you've ever gone through. You've learned lessons from your past designs and you're putting into practice, putting the APs in the best spot. And then you push out the configuration to your access points and your users are complaining. And now you're scratching your head wondering, why is this happening? My design was so beautiful, right? It was the best of the best design, right? And this is where you can run into an issue, is the configuration that's running on your wireless deployment doesn't match necessarily what you modeled in the software, right? So if you were leveraging one of the auto RF protocols, right, where it's automatically assigning a range of transmit powers to the access points, if you haven't dialed in that range, right? So instead of letting it go all the way to the floor and all the way to the ceiling, so going all the way min and max power, there's too much wiggle room in those access points, and they can run into some challenges where they're not able to recover, right? And this is a problem that could exist in many vendors' platforms, right? So you just want to be aware of the configuration to make sure that you're setting your minimum data rates, you're setting the upper and lower range of those auto RF thresholds, so that the APs aren't getting too hot or too low. And one of the really cool things that I like to do in Ekahau is, once you've built your model, and Matt kind of showed this earlier in the webinars, if you don't know the exact attenuation of the walls, you can model the what if scenarios. What if my walls were only 3 dB thick? What if they were 6 dB thick, right? Will my design hold up? And you kind of cover the extreme ends of that. You could also do the same thing with transmit power. What if my APs crank up their power to 17 or 20 dBm, right? Will that be too hot? Will I have too much channel interference? Or what if they go down to the minimum, right? If I set my range to drop down to 8 dBm, right? Will I have any coverage holes in that scenario? So you can test that out very quickly in Ekahau. What if my APs recover the full range of what I'm allowing in my configuration? Will my design still hold up in those scenarios? And validate that before you actually push it out into your configuration. Okay. And if you need some help with that, you can also leverage Ekahau Optimizer to give you recommendations on how you can improve your configuration based on some suggested best practices, right? And with these best practices, we're not saying that they're the law. Once you know where these best practice recommendations come from, you can bend them or you can even break the rules, right? But if you want a very quick, easy button as just a quick check, a sanity check even, am I following reasonable best practices in my configuration, or was there something I missed, right? Did I accidentally forget to add APs to the right RF group? Did I forget to remove some channels that I didn't want allowed? Have I left 80 megahertz as my default on 5 gigahertz instead of cranking it down to 40 or 20 or something like that? Do a quick sanity check, what's going on with your configuration, get some suggestions. right? So we try and make it easy by color coding them red, orange, green, right? So the traffic lights of issues. And if there's anything that's red or orange, right, maybe it's just something you accidentally forgot to configure correctly, or maybe you can justify it to yourself. Yeah, it's showing as orange, but I intentionally deviated from the best practice for whatever reason, right? So I always like to use this as a quick sanity check, just see if there was anything that I missed in my configuration.
Yeah, thank you, Troy. Before we jump onto the next couple of slides, I've just been taking a quick look at the Q&A, and I think we can probably answer a few of these questions quickly now. So one of the questions was around what are our thoughts on some of the new vendor access points now offering internal directional antennas for using on large areas with high ceilings, as opposed to the traditionally having to use external omnidirectional antennas that have been deployed. So I think that the integrated directional antenna access points that's starting to come out now are very good. They especially help with the low power indoor requirements with 6 GHz. So when you've got high ceilings, or if you've got warehouse racks or auditoriums and you need to have that focused energy, before we get the standard power and being able to use external antenna model access points, we were kind of limited to just using the integrated omnidirectional. So I think they've been a real great help and really good innovation for us to be able to design and deploy RF the way that we want them to and still meet all of those new requirements we need to think of. Also, it can help with architectural and aesthetic concerns too. So I definitely think that that's a great new thing that we have. But some of the directionality of the antennas, they're a bit wide still for some of the use cases that you might need. Like if you've got a warehouse that's got super narrow aisles, but they're really, really long, then you are going to want to use more directional antennas. I think most of them are around like 6 dBi gain. Some of the antennas that you may want to use are going to be 13 dBi gain. So I think it solved a problem that we had for a while. But now that, especially in some parts of the world where we're going to be able to start using external antennas with 6 GHz capable access points, we're going to go back to seeing a lot of them in use. Another question in here was around the um, use of 11K in directional antennas. I think I mentioned 11K a minute ago. 11K is great for helping speed up roaming time for client devices. Usually, I'm not aware of any implications or issues with implementing 802.11K, whereas different roaming amendments that are there to assist, like 11R and 11B, sometimes can have some client compatibility issues. But as far as I'm aware, 11K has been fine. So yes, you do use directional antennas and do use 802.11K. And one more final question was, if the hallway is short, does the rule still apply? In a rare occasion, I placed in short hallways to be used for roaming. Of course, there's going to be some times when you can bend the rules if you've got, like you said, very short hallways, and depending on this type of environment it was, placing an access point in the hallway might be completely fine. But in general, as a rule of thumb, for large hospitals, hotels, student accommodation, you're going to find a better performance and result from putting access points inside of the rooms. Troy made a really great point there about sometimes you have different thickness and different attenuation values for the walls in the hallways. And again, we typically want to put access points and Wi-Fi where our clients are going to be mostly using the network, which will be inside of the rooms. Okay.
Yeah, there's a school that I was working at. It was a very technical driven school. So all the kids were issued laptops in the higher grades, tablets in the lower grades, and they'd very regularly break off into group activities. And when they broke out into the group activities, they'd go into the hallways, right? So the little nooks, there were little cushioned chairs, desk, little areas different groups would go to. And so a lot of the schoolwork was done actually in the hallways itself. So at that school, we wanted Wi-Fi coverage in the hallways. We didn't just want to focus on in the classrooms, but there we intentionally used directional antennas in the hallways to focus that energy in the hallways, so that we weren't trying to cover the classrooms with that. But ask, as part of gathering the requirements, where do you need coverage? How are your users using the Wi-Fi? And in that scenario, hallway coverage became quite critical, quite important for that particular school.
Okay, great. So there was one thing I wanted to show you quickly. We have a new solution for Optimizer that actually you can now remotely review and optimize your networks without going to site to do the survey. So we're referring to this as the remote optimizer. So let me just give you a quick demo of how this actually works. So if I just fire up Optimizer, what it is going to require you for now is to have an API key to your vendor dashboard. We are just supporting Meraki as of now, but we will be including more vendors very soon. But what I can do now is if I use the API key, I select my organization, I can see that we've got 3 networks here, but if you had 30, 300 or 3000, you could see all of them and pull that information in. But if I click on the production network, what it does is it goes and fetches the data back from the dashboard, and then we'll do some recommendation best practices checks against how you've configured that network if it's in line with best practices. So we can see we've got a few cards here, and I can click on any one of these, like the minimum basic rate, for example, and we can see what we've got currently enabled right now, 9 megs everywhere on 2.45 and 6. So clearly we practice what we preach at Ekahau with not using some of the non-default minimum basic rates. So yeah, we might want to make that change. We can check for things like roaming settings if we've got 11R enabled or disabled on .1x networks. We check for other things too around like firmware upgrades and how your SSIDs are configured, if they're in line with best practices, like not having the same SID on both frequency bands on 2.4 and 5. And then you can review the action plan. So the actual changes that we're recommending to make around the channels, transmit power, you can see the network configuration recommendation changes as well. And then if you want to, you can actually go ahead and deploy this to the network by simply clicking on deploy to network. You kind of review the changes here, click next, 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 and then you have an option to create a profile only or to create and apply the profile to the access point radios, and then you just confirm your choice, hit deploy. It's going to go ahead and make those changes. So really nice thing to do if you've got lots of networks that you've got to manage, to give you an idea of how things are configured and see if there's some quick wins that you can do to improve the performance of the network. So moving on to worst mistake number 7, Troy, and that's going to be around capacity.
Yeah, which is such a double-edged sword when you talk about capacity. In today's designs, it's a critical thing that you want to include in your designs, but it's one of those garbage in, garbage out stories, right? So many people overestimate their capacity requirements. They add all that data into Ekahau, produce their model, and then they're trying to resolve their capacity challenge by adding more access points. And the more access points you add, eventually they tip the scales and they start creating too much co-channel interference. And now you get lost spending, hours and hours trying to resolve coverage and tweak the position of access points, flip to directional antennas, trying to solve a problem that doesn't really exist. And it's because you're overestimating your capacity requirements, right? So I work with so many customers that start asking for, hey, we need 10 gigs or, a crazy amount of Wi-Fi capacity and for a relatively small space. And we're like, wow, we can design that network. Like it's certainly not going to be cheap. And we're probably going to be using RF shielding paint or stickers on walls to block or limit the propagation of signals. We can do that and provide you, that 10 gig of Wi-Fi capacity. But one of the reality questions I like to ask is, when we deliver this for you, that 10 gig Wi capacity, just help me understand, where is all that traffic going? Right? And a lot of the stories, they're looking at cloud resources, cloud shares, a data center that they have centralized for all their regional sites. And they're like, yeah, we're going to send everything back to our central point or out through our WAN link. And over the summer, we just upgraded our WAN link. We now support 500 megs symmetric, 500 up, 500 down. And they're very excited about their shiny new 500 meg link. And you're like, there's a big disconnect here. You're asking for 10 gigs of Wi-Fi capacity to squeeze over your 500 meg link. Right? Something doesn't add up. I just want to level set with you guys. Are you over designing your network for capacity, right? And one of the cool things in Ekahau is that you can model that and kind of help give yourself a reality check. Have you over designed capacity, or are you in the realm of reason?
So yeah, whilst Troy was mentioning capacity, I thought maybe it'd be nice to show you how you can actually do that inside of Ekahau AI Pro Online. So what actually happens when you define an area in AI Pro Online, we will actually automatically try and calculate or estimate how many devices we think you're going to have inside of that area based on the size of the area, but you can then of course come into it and then reconfigure it yourself as well. So what I'm just going to focus on here is this auditorium space. So I've defined a smaller area inside the larger area, and we are going to now say that we need to have 50 clients on 2.4 gigahertz, 200 clients on 5 gigahertz, and then 100 clients on 6 gigahertz. And then you can assign a traffic type. So you have the option of either low, basic, or high. And effectively, what this is going to do or limit and try and show you is, have you got too many devices trying to connect to a radio of your access point in the space that you've got defined here. So at the moment it's set to basic. So that's saying we don't want any more than 30 devices per radio. And based on configuring 200 devices on 5 gigahertz, what you can see here is it's showing that we are going to have too many client devices trying to connect to each radio of the access point. So 39 over 30 here, 51 over 30 here, etc., etc. But if I wanted to, I could come and change that from being from basic to low, and that is going to change and now show that we could have basically up to 50 clients per radio. And if you're not happy with that configuration, what you can do is you can come in here and create your own custom option and change it to be, I don't know, maybe you're happier with 60 or maybe you want it to be 20, and you can go ahead, make that change once you're happy with it, and then you can check to see if you've defined the amount of clients for your capacity appropriately. Okay, so moving on to the next mistake is not identifying some security vulnerabilities. So, Troy, I think you've got some nice examples here, right?
Yeah, absolutely. Right. So as you walk around your environment, due to regulatory compliance, you want to make sure that there aren't any access points that are running weak or poorly configured security protocols. You may also have employees that bring in their own access points and plug those APs into your wired network because they want easy Wi-Fi connectivity to help them achieve some task. Now, they're doing that because they think that they can be a better employee, they can work faster, get more stuff accomplished. They're not trying to do anything malicious, but they don't know how to properly configure that wireless access point that they just went out to the local big box store, bought, plugged it into the network, and now it's configured using WEP or something crazy like that, right? And now this poorly configured AP gives a vector or a conduit for malicious individuals to get access to your wired network, which can be problematic, right? So while you're doing your surveys, some of the information that we're collecting and we highlight for you is if there are any of those access points that are creating signals that are quite loud, suggesting that they're inside the walls of your building, possibly plugged into your wired network. We flag them so that you can go identify what those access points are, if they're legitimately allowed to be there. They may be totally isolated APs, part of building control on their own dedicated network, independent of yours. But it's something that you want to flag and be aware of so that you can make sure that you're compliant with whatever regulatory rules that you need to adhere to.
Yeah, and then what you can see is we actually did a survey of one
Right.
of our
And then, oh,
sorry, Troy, you lagged a little bit there. I think the connection got a
oh,
bit
go ahead,
behind.
Matt.
No, I was just going to tell everyone what you can see in the picture here is coverage from one of the rogue devices that we detected during a survey highlighted in red. And one of the things that we noticed around the corporate network was that in this scenario, they hadn't enabled management frame protection. So what we was able to kind of test doing in this scenario was trying to get people off of the legitimate corporate network to then go and connect to that rogue access point instead. So we had configured the rogue AP to have the same SSID as the genuine corporate network. And then we used this device here, the flipper, to send out like a deauthentication attack on the same channel that the genuine corporate device was on connected to the access point. And when you send this deauthentication attack, without management frame protection enabled, what happened was is that the genuine corporate device got disconnected from the corporate access point and then reassociated to the rogue AP. So this is a real fine example of what you really want to avoid as much as possible. And one of the ways that you can kind of protect yourself from this type of attack is by enabling management frame protection on your SSIDs. So we run the exact same test again using the same equipment, same devices, but this time we just enable management frame protection. And if you've not seen this screen before, this is from the network overview of our analyzer application. So this is what you can see here that we have it enabled. And then when we did the exact same the authentication attack, this time we started it, but nothing happened. The client device doesn't get disconnected from the network. It stays associated to your corporate network. So this is definitely something that I would recommend that you enable on your SSIDs if you can. Just one thing to watch out for is that you do have some client devices that might have client compatibility issues. So just keep that in mind. But I do try and recommend to as many people as possible to use the most secure methods that you can around authentication and security. Then a quick little bonus picture. Going to see a device now that we probably see. Troy, I know you've probably seen this about 100,000 million times during your wireless surveys. There's always some kind of device that has this RF enabled when it shouldn't have been. So again, in this example here, we found the most typical culprit, a printer that has its Wi-Fi enabled, even though it's got a corporate LAN physically connected to it. So it doesn't need to have its Wi-Fi enabled. And not only is it a security vulnerability, it also causes you channel interference on your network. So if you can, go find them, disable the radio, and then just connect to the printer through the corporate network rather than disconnecting and then associating to the Wi-Fi there. So we know that there's wireless security vulnerabilities pretty much everywhere. So we do what we can to try and help you identify them just from walking around with Ekahau. We show you the exact location on the map, the impact that is having, and then you can go and find and resolve them as well. So Troy, worst mistake number 9.
Yeah, it's a classic problem. I think a lot of people that come from the wired side of networking fall into the trap of turning on rate limiting. And it makes a lot of sense on your traditional Ethernet cables running to desktops users. You want to control how much traffic, especially guest users on your network are consuming. So a lot of people get worried about people consuming too much Wi-Fi bandwidths, right? So they come up with the idea that, hey, we want to turn on rate limiting. And it just works differently in Wi-Fi, right? So the long story short of this is, do not rate limit your Wi-Fi traffic, right? It just causes more issues than it provides benefit, right? The same amount of traffic is going to be sent whether you rate limit or not, right? If you turn on a rate limit, it just takes longer to transfer that file. And the more time it takes to transfer that file, that means the more active that client is over an extended period of time, eating up airtime, right? It'd be much more beneficial for your organization if your users allowed to access that resource anyway, download that file, that particular application, let them get on and off as fast as they can, and then stop talking. Right, so the other clients can transmit their data. If you extend that activity, it ends up impacting everybody else, right? So in Wi-Fi, it's generally a bad idea to enable rate limiting, right? We just don't get the airtime benefits that a lot of people think they do, and it actually makes the situation worse and more frustrating for your users. All right, and then we just have here a little sticker that my daughter made for me. She was inspired by the story about doing AP on a stick surveys, right? And so the idea here is it's super important. A classic mistake that junior surveyors make is they forget to freeze their access points in the software when they move their AP on a stick from one location to the next, right? So the sticker is inspired by living in Canada in the winter. Things get pretty cold. Our metal poles, stop signs, they freeze. And little kids dare their buddy to stick their tongue to a metal pole. And if you stick your tongue to the pole, if you really slobber up your tongue and you peel it off, it leaves flesh behind on that pole, right? So now it's a little bit of blood. You're going home crying to mom or the teacher, whoever. They shake their head and they remind you not to do that next year, right? So I got these stickers that I set up on my AP on a stick rigs whenever I'm doing those AP on a stick tests. And I have the stickers there to remind me that when I go to reach out to grab that tripod, remember silly little Canadian kids and their tongues frozen to metal poles. Ask yourself, did you freeze the AP? And make sure you do that before moving to the next location to test the next AP on a stick spot.
Troy, I think you're gonna have to figure out a way that you can get some of these stickers to some of the people in the webinar chat. People are saying that they want to have this sticker for the next time that they're doing an AP on a stick survey as well.
Yeah, absolutely. So I bring them to a lot of the conferences. So if you happen to run into me at something like Cisco Live, HP Discover, WLPC, something like that, I often have these stickers with me, and I'm more than happy to hand them out.
Mhm. Okay, worst mistake number 11, and the last one for today. not joining our next webinar. So make sure that you get yourself signed up nice and early, because actually the next webinar is going to be a really interesting one. So it's going to be about the case study that we recently did with Boingo around deploying real crucial networks for connectivity and not just Wi-Fi, so wireless. So how they designed, deployed the Wi-Fi network, but also making sure the connectivity was good for the cellular aspect of it as well. So this is going to be a really interesting one. We can't wait to have Boingo to join us on the webinar to talk through some of these deployments. We was fortunate to do a case study with them in person recently at a Phoenix airport. So if you haven't seen that, you can find that on the website as well. But do get yourself signed up because this will be a really interesting one too. So that does conclude the content for the webinar today, but I can see that we've got loads of questions in the chat and the Q&A. So Dale, if you want to maybe come back and you can fire some of these questions over to us if you don't mind.
Yes, certainly. So, few questions that I noted to ask here. So, one of those is a question that says, "I've completed a wireless survey of the four-level garage where we currently have two access points per floor. Given the large size of the garage, the existing coverage does not provide full wireless coverage across all areas. I'm looking to improve the coverage and would like your input. Should I create a new wireless design for the garage, or can I simply add simulated APs to the existing survey data? My goal is to leverage the survey tool's capability to automatically account for attenuation and surrounding materials to provide a predicted coverage map for the proposed APs." So
That was
just the solution in place for that, right?
yeah, I mean that was a great long question, and I'll take this one, Troy. Maybe you can take the next one. But great question, and there are a few options you can take here, but the one that I think would probably be the best solution for you is to leverage Ekahau AI Pro Online. And let me just see if I was presenting today at Cisco actually about just this as well. So let me just see if I can find my slide on that quickly, and then I can just show you a very quick example. Owned by me. And yeah, found it. Let me go ahead and share my screen again. So if I share desktop. So the thing about Ekahau AI Pro Online is we give you kind of like two options to how you can then predict and model out your space now. So the one on the right hand side is probably very familiar to all of you hundreds and thousands of people on the webinar today, where you would upload a floor plan, define a scale, you add the attenuation values for all of your materials like walls and cubicles and warehouse racks, etc., and then place your simulated access points on the floor plan, and then we predict and show you the heat map and coverage. That's the way that we've been doing predictive modeling for years and years and years. However, recently we come up with a new way that you can redesign or design a new network using measured survey data collected by the Sidekick 2. So in your scenario with your four-floor garage, if I turn on my American accent, the thing that you could do is walk around the environment, go through your four floors that you have, collect the data with the Sidekick 2, and then upload that to Ekahau AI Pro Online. And what you'll be able to do is see if you've got any kind of coverage, the coverage gaps that you have. Without having to draw any kind of walls or any kind of obstacles, you can add in additional access points. You could even swap out your current ones to be newer model 6 gigahertz capable access points, and then you can kind of fill in those gaps. So let me just see if I can find a quick project file to demo to you guys. So let me open this one quickly, and I'm just going to show you what we have here. So at the moment, this is a survey that I did of an office space, and it was just a 2.4 and 5 gigahertz network. So you can see just 2.4 and 5 gigahertz here. I haven't drawn any walls or any obstacles. So this is just survey data that I pushed to Ekahau AI Pro Online, and I can see the coverage coming from the access point. But let's say that I wanted to relocate this access point. Maybe I had a coverage gap over here and I wanted to move this access point. Rather than having to draw in all of the walls now manually and then add in all of the attenuation values accurately, what I can do is just grab the access point and move it around, and it will simulate the changes. We build um, we use AI and machine learning based off the RF data collected to really understand how RF propagates in your environment, so you can account and make these kind of changes and tweaks. So you can see I've just moved the access point to here. But maybe what I wanted to do is actually upgrade all of these access points to be 6 GHz capable ones. We can do that too. So I just simply select all of these access points, and I can actually swap this out now to be a 6 GHz Wi-Fi 7 AP. So as soon as I click on this, what you'll notice is that the colors of the access point radius are going to change from green to orange. Hopefully you saw that because it did happen pretty quick. And then now if I change from 5 GHz, I have the 6 GHz option too. So I can now view and simulate upgrading to a 6 GHz capable access point network and see if I can keep some of those existing AP locations, or maybe I need to add some extra ones. If I notice there's a big coverage gap here, I could place an additional access point, or I could move some things around to account for those changes. So I know that was a long way to answer the question, but I thought it'd be nice to actually show you a way that you can do it too as well. So yeah, I would recommend go do a survey with your sidekick, upload it to Ekahau AI Pro Online, add in some additional access points, fill in those coverage gaps, and have a great performing Wi-Fi network. So Dale, I'll let you fire over the next question for Troy.
All right, Troy. So here's another question that was upvoted, so I figured I'd ask. Now, oftentimes the omnidirectional internal antenna APs might not be, ideal for warehouse environments, but whenever, they don't have much of a choice outside of that, what is the ideal maximum height for mounting those on higher ceilings? What point do you not want to go higher than typically if using those?
Yeah, so there I would absolutely say 42 feet or 42 meters is my cutoff for that. No, that's just a cheeky way of saying it. It depends whenever I answer 42 to one of those number questions. There are a lot of contributing factors to that. I don't have all the details why Omni is the only option that's available. Sometimes it's a matter of pushing harder, but it sounds like they pushed back as hard as they could, that Omni is the way it is. My general rule of thumb is at about 20 feet or about, in that 4 to 5 meter mark. That's generally where I'd like to switch from omnis to directionals, right? When I'm that distance away from my client devices or my users, that's my threshold for making that cutoff. I would also, in that case, if I'm being forced to use omnidirectional antennas, as part of my design, I'd work harder to try get those APs closer to the users, right? Which may mean mounting them on walls, right? And it could be mounting them like clocks, or maybe using those 90-degree brackets, or lowering the APs from the ceiling using all thread or some sort of hanging suspension cables, just to get the APs lower and closer to the clients, if that's what I'm limited to as part of my AP model that I can use as part of my design.
I would just add one thing to that, because I know if I don't, Dobius will probably kill me next time I see him, because he brings me up on this every single time it comes up. Also, some of the access point AP vendor, AP vendors have access points that, even if they're omnidirectional, they support down tilt antennas. So that might mean that if you are limited to using an omnidirectional access point, you can find some vendors that have got down tilt built into their omnidirectional integrated access point. So that might mean that you could go a little bit higher, because I totally agree with Troy. 4 to 5 meters is the kind of cutoff point where I like to feel safe using omnis, but you might have the ability to use these access points that have the down tilt antennas built into them to go a bit higher. But again, lots of variables there, and it really does come down to budget, your environment, what AP you can use. But yeah, trying to bring them down lower if you can, or switch to directional antennas or integrated directional antenna access points.
Thanks, guys.
Okay.
Want to ask
Any
any
other?
more? Or is it about that
Yeah.
time? I know we're like 12 after the hour.
Um, well, there's people in the chat calling you beautiful, Troy. So maybe we
Oh,
can answer. Maybe we do one or two quick ones, and then we'll let everybody go.
All right, there's one more that I noted here that was upvoted. So, this one's more so in general, but we are at that point in the paradigm shift where people are starting to go 6 GHz. So this one says, getting ready to deploy 6E for the first time. Any design considerations specific to 6 GHz?
Yes, quite a lot of things to consider when it comes to 6 GHz, especially around the new rules for different device classifications. You've got low power indoor, you've got standard power, um, you've got AFC to consider. Do you need to put any of these access points outdoors? So it really would come down to where you're going to be designing and deploying 6 GHz. But one thing to bear in mind is that the 6 GHz access points, you may it's still the same design principles apply, that you should define your requirements, you should go on site, do a proper survey and understand your environment, build out your model appropriately using Ekahau AI Pro Online, and making sure you've got everything designed adequately that you can see in there. And then when you go and actually deploy it, making sure you validate the network. But we could probably spend another hour or three talking about 6 GHz. We have got quite a few webinars that we've done in the past around 6 GHz and a great guide on upgrading to 6 GHz. Things to think about is around channels, what channel widths you're going to use, but again, depends on where you are in the world. So I would say maybe just check out the Ekahau website, search 6 GHz. We've got lots and lots of great content on there. But yeah, good luck with your deployment for 6E. It's going to be very good, I'm sure, and check out some of the content that we've already got out there. I can see a few people put a link to some of those guides in the chat as well.
Mhm.
Okay, well, since we're quite a bit over the top of the hour, thank you so much everyone that stayed on with us today. We love having all of you guys and girls with us. Hope you enjoyed the content today. We look forward to seeing you in a couple of weeks' time on the webinar that we're going to be doing with Boingo. And enjoy the rest of your Thursday, whether it's your morning, afternoon, or evening. And yeah, have a great rest of the day. And thank you from everyone at the Ekahau team.
Yeah. Thanks, everyone.
Thank you all.